What we're going to do is extend factoring to the next level. All right, we're just going to take it up a notch, take factoring beyond just what you were doing as a review yesterday. Like, this is still technically a review because you did do it last year and probably a little bit in Algebra 1. But we're going to, each time we're adding layers and it's just getting a little bit more challenging, a little bit more complex functions. All right, what you need to do when you're solving. Well, let's do the difference. If it says factoring is getting into parentheses form, and that's what you were doing yesterday, getting a polynomial into the form of parentheses. That's factoring. We're going to take that the next level, and we're going to go to solving, which is taking the parentheses all equal to 0. So it's just an extension of what we did yesterday. So just be watching for the instructions because your homework is divided onto 2 pages. And one page is only the factoring part, and the second page is the solving part. But like Emma had her question earlier about doing too much, you may not read the directions very carefully, and you may end up on the part where you're only supposed to factor, you may end up solving it, which means you're doing more work than you need to because you're going beyond. So I'm just trying to save you work. It's half and half on the homework. All right, so setting all parentheses equal to 0. Here's the question, at least the first one. Solve. So we're going to solve 2x to the second minus 2 equals 3x. Now there's 2 terms on one side and 1 term on the other. Just because there's 2 terms doesn't mean this is a GCF problem. You count up your terms after you have it equal to 0. You have to make one side completely equal to 0 before you can get going. So what's the easiest way to do that? Subtract 3x. And so I'm going to kick the 3x over to the side with everything else. And now I have a 3 term, which is called a trinomial. And from yesterday, the strategy for approaching a 3 term or a trinomial is what? Star. All right, so we're going to apply star here. So we've got -4 and -3. So clearly it's going to be 4 and 1 as my numbers, but which one is which? Which one gets the negative? The 4. So then I'm going to use, replace the -3 in the middle. So I'll have 2x to the second minus a single 4 or minus 4x plus 1x minus 2. This becomes now a 4-term problem, which is going to be split. So we'll split that in half. And to the right side and the left side, we're going to apply the GCF. What's the GCF on the left? 2x. That leaves me with x minus 2. What's the GCF on the right? 1. There's always a GCF. Okay, don't get sucked into thinking that you can't take anything out. You always can, and you're still left with x minus 2, but it's still equal to 0. Yes, ma'am? If you're comfortable with that and you are not going to make mistakes, then you are welcome to do it that way. Okay. All right, so we're going to you'll end up at the same place either way. You're going to get x minus 2 and 2x with a positive 1 as your factors. So that's called factoring. So if the directions say factor, then stop here. If the directions say solve, then you got to keep going. And you have to take each parenthesis and you set them equal to 0 independently of each other. And so you'll have x minus 2 equals 0 and 2x plus 1 equals 0. Then those become what you solve. And so one, I just quick add 2 to both sides. So x is equal to 2. And the other, we're going to subtract 1 and then divide by 2. So we get x equal to -1/2. These are called x-intercepts. All right, so the 2 and the -1/2 are called x-intercepts. An x-intercept is where a graph would cross the x-axis. So when your questions ask you to confirm it by graphing, you're going to grab out your graphing calculator, which we'll do right now. First, you want to make sure all your plots are off from the last time you did graphing, and you want to make sure your window is -10 to 10. We've got a graph whose parabola comes down and crosses the x-axis, and it confirms that we did our math right. That first spot, it's crossing at -1/2, and the second spot, it's crossing as 2, which confirms the 2 x-intercepts that we had from before. So you can use graphing to double check your work. If you don't have access to the answers in the back of the book, you can always check a graph. All right, example 2. This time we're going to be asked to solve the equation x times 3x plus 11 equals the number 4. Again, we still want this equal to 0, but what are we going to have to do first before we can make that happen? Right, all right, so we're going to distribute. That's going to give me 3x to the second plus 11x, and that equals 4. Before you can do anything star, GCF, or split, it has to be set equal to 0. So we'll have 3x to the second plus 11x minus 4, and then that's equal to 0. Now that's also what we're going to be able to graph. The first thing that's equal to 0 is what you'll eventually graph on the calculator. At this point, we'll do our star, -12 on the top, and +11. So to get -12 and 11, we're going to have 12 and some kind of combination of 12 and 1. But which one of them is negative? The 1 has to be negative in order to make sure that we end up with the right answer. So we'll have 3x squared plus a +12x minus 1x plus 11. And now we're ready to do the split method. Oh, right. There we go. Okay, on the left side, what can I pull out as my GCF? 3x, leaving me with x plus 4. What about on the right side? What will the GCF be? It'll be a negative number. It'll be -1, so that I'm left with x plus 4. That's equal to 0. So the factors I've pulled out are x plus 4, and the other factor is 3x minus 1, which is still equal to 0. So remember, if you've only asked for factoring, this is where you stop. These are the factors. Factors are in the form of parentheses. If they ask you to find the x-intercepts or the solutions, then you take each factor and you go the next step. So x plus 4 is set equal to 0, so x has to be minus 4. 3x minus 1 is set equal to 0, so 3x equals 1, so x equals 1/3. All right, would you go ahead and graph this on your calculator also and confirm that that's where the x-intercepts are? Remember, you're graphing the first thing that was equal to 0, so you'll be graphing 3x squared plus 11x minus 4, and you're double checking that the place it does cross where we thought it should. And I believe you're going to see a graph that looks like this. And so it should be evident that we're crossing at a -4, and then it's not so obvious we're crossing at 1/3, but it's definitely closer to 0 than it is to 1. All right, any questions so far? Yeah.
On the homework, are we supposed to draw a graph?
Just like what I just did. It doesn't have to be on graph paper. Just something that shows me the general shape crossing in approximately the right places. Okay? But it does not have to be, this is not one you have to do on graph paper and submit in Canvas or anything. All right, last one. All right, we're going to start with 4x squared minus 6x minus 9. That's going to be one side. Then it's going to be equal to x squared plus x times the quantity x minus 5 plus 6. So again, we're going to want to make sure that we've cleaned this up to the point where it's equal to 0, but my first step is to do what? Distribute. So when I distribute, then I'll be able to combine like terms. And so we're going to distribute, we get x squared minus 5x plus 6. So that gives me 2x squared terms on the right-hand side. So altogether, I'm going to have 2x squared minus 5x plus 6. And I haven't really done anything on the left side yet. All right, let's see. Lucinda, can you tell me what to do and I'll do it to get this equal to 0. What should I do first? That sounds good. All right, move everything on the right-hand side over to the left. So I'm going to subtract 2x squared. That's going to give me 2x squared. I'm going to add 5x. That's going to give me negative 1x. And I'm going to subtract 6, and that's going to give me negative 15. So I'm going to move everything from one side to the other. And now it's equal to 0. That'll be what I'm going to graph in my graphing calculator. All right, the first time that you're equal to 0, that's what you're going to graph. In the meantime, we're going to apply the star again because this is a trinomial. So negative 30 and negative 1. So that's going to have to be a 6 and a 5 of some kind. Which one gets the negative this time? The 6. That's so that I can make it be equal to negative 1. So I'm going to have 2x to the second minus 6x, but a positive 5x minus 15. And I can split factor this. On the left side, we're going to take out the common term of 2x, which leaves me with x minus 3. And on the right side, what will I be pulling out? 5. I heard 5, a positive 5. So that will leave me again with x minus 3, still equal to 0. So my factors are x minus 3 and 2x plus 5. So those are the factors. To find the x-intercepts, or the solutions, we will keep going, setting them independently equal to 0, and we'll get 3, and we'll get 2x equals 5, so x is 5 over 2. And so any graph that you make should confirm that it's crossing at 3 and at 2.5, which is actually really close to each other. And remember, what you're graphing is always the first thing. What did I do wrong this time? Oh, I didn't subtract. Always graphing the first thing that's equal to 0. So I'm going to switch over to my calculator. Quick sketch just to confirm. Doesn't have to be perfect. Just showing that indeed it did cross at 3 and negative 5 over 2.